in hot. I'm coming in efficient. I'm coming in hot. Today I'm ready. I have a to-do list. So, first off, yeah. Okay. Okay, so the first thing we just need to reprint is when we go to here, right, so hold on. I'm not connected to the internet. Is that true? Okay, so we miscalculated. So if I go to the ball shooter and I go to the assembly, I was being really dumb because hold on. Oh wait, no, I didn't want to open up the assembly. I wanted to open up this. I don't really know what I'm doing here. What is out of date about this? Okay, well, in any case, we activate top plate and we see this. Now, the hilarious thing, I should have known because this wasn't mirrored, but this is 85 apart. But then this is 69. So we need 85 plus 69. So when we go to this and we go to this parameter, this is going to be 85 plus 69 over 2. 77. Okay, so now it seems a little shorter together. But now we need to adjust so the distance between here and here is 18. And between is 23. So we need this. So it's going to be, so you have, what was it? I forgot the number. Wait, 85 plus 154. Dude, I lost my paper. I don't know where my paper is. Whoa, what is this? Invalid number input? Anyways, so when we go to, yeah, platform, this is the thing that we need to now make a formula. And it's going to be, so half of this distance, yeah, is going to be, so hold on. Yeah, so let's just do this. 85 plus 69 over 2. And then this, that is the distance from the center to the very edge. That's 77. I'm pretty sure we want to subtract off like 23. And that's just a coincidence with this. And then we want to also subtract off maybe 10 more. 44. Because now the distance from here to here is like 8. Which is good because that, which means that this to this is 3. Which is like kind of a nice amount of clearance. So, yeah, it's kind of sucks that we messed that up, but let's just... So flywheels of 70. Yeah. Okay. So let's just save it and print it because oh yeah, I got to show off this really cool thing that I did. Okay, so I've been using Fusion scripts for basically everything. So, well, not for everything, but like for a lot of stuff. So I made this export params to JSON thing. Okay, and now I just go to this, and I'm pretty sure it just overwrites it. So now if I go here, import params for JSON, and I go into here, and it's going to be this one, it made it smaller. So now this is 70.775, which is perfect. So now we can just export both of these again and print them. Unfortunately, it takes so long to print stuff. That's the worst thing, is that you have to wait. But we have a lot of other stuff to do. But so 2v2, 2v2. Okay. So now this needs to be, and then we need to do this. Arrange, auto, then we need to go to, oh yeah, we need to switch this. This is so annoying. I just need to take out this ABS. Because it's so, oh, wait, can we just use up my red, actually? I just want to use up my red. Okay, so now we need to go to global. Support is enabled. It's going to do it like this. But I don't really like... Well, why don't we try it this way? Let's see how long it is. It's probably going to be longer, though, because of all of the supports. 339. Look at that huge block of support. Ay, ay, ay. Whatever, that's how it recommends it. I think that the problem that I really didn't like was that, honestly, it wasn't that bad, but the supports on the underside of this when you flip it over, because if we do this, if we go back to here and we do lay on face of this, okay, that's good. Then we reslice it. Now we get 20 minutes faster, and this was 120. So if we 120 grams, and then this is 140 grams. It also, I don't know how hard it's going to be to get this off of here. We're going to try it. I'd like to try it this way. So, yeah, so this is the PLA in A2. That might be the actually... I think that this is the one that I want. Okay, so let's just send it. Okay, so nice. We can check off one. Okay, so now, I'll probably need to go solder something because... What was this thing about, what is NDI, dude? I do not understand what this actually is. Network device interface is a software specification. It enables high-def video to be transmitted over a computer network with low latency and high quality. Oh, by the way, I got a Raspberry Pi, and I got the PiCam working. Pretty nice. The problem is OBS does not compile to AArch yet. So that's kind of annoying. But whatever. I need a pee. I guess, yeah, I'm gonna solder. So, okay, so last night I burned 2 of the magnetic encoders because, let me just see if I can show it. Okay. So out of an electronic speed controller, there's 2 cables that go to a power supply, 3 cables that come out, and then 3 cables that go to the receiver. Now the receiver on a drone, because these are drone motors, needs power also. However, my Pico is already powered by my USB. And so I plugged in the 5 volts and ground to my breadboard, but then the 5 volts going to the magnetic encoder, it was just too much, I guess. The only thing I really need is this white going to a digital pin. So, and the thing is, last night was so stupid. I saw 3 cables, and I was like, wait, well, where did the other 2 go? It's like I didn't need them. So I figured it out yesterday, but whatever. Okay. Ba boy. So we need to. I want to read this actually. Actually, that's a good question. So, can I just look this up? Dual PC, no capture card. That low-key sounds like what I want. Easiest 2 PC stream set. Oh my god. Dude, this would be hype. What's OBS teleport? Open ND like oh, that's sick. For an open NDI like replacement. No NDI See, that's great. Who is this guy? Dude, I love OBS developers. Bro, it's funny because they never even like stream. They just work on streaming shit. What the hell? This is his website? Okay. That's sick. What a hype guy. So, it's written in Go? It's written in Go? How did he manage that? There must be good interrupt with C++ or something. An OBS Studio plugin for an open NDI-like replacement. So wait, let's watch some videos. So first this. Bro, wait, okay. It's pretty clear that I want to use this teleport thing. This looks like a good video.
Several of my most popular videos have been about the OBS NDI plugin for 2 or more PCs. Unfortunately, the development plugin has been OBS, and now the exactly the same thing. I've been a big proponent of NDI and have even used it to stream LAN parties and other special events, as well as inspiring friends like the Toasty Bros and Christopher E to use them occasionally in their own streams. I always preferred the simpler OBS to OBS method with NDI, which completely relied on the old plugin, and unfortunately, this would occasionally have audio DC issues that were difficult to overcome. You're not being fed, shut up. So the first thing I checked before trying this new OBS teleport plugin was the reviews, and it made me feel good to see that there were comments specifically talking about not having any audio DC. Perfect. So let's get down to the desktop and I'll show you how to set it up. It's super simple. So here we are at the desktop of the gaming computer. This is where you're going to want to set up your gameplay inside of OBS, as well as any overlays or anything like that that you're going to do. If you're going to do it that way. So first things first, Google the OBS teleport plugin, and then you open OBS teleport here, extract, download, over to start OBS, put it in.
Oh, it has an installer?
And then you click teleport. You see it right there. It's in that list of tools. That's how you know the plugin installed correctly. Editing Chris here. I forgot to mention that before you enable teleport, you need to go into your video settings in OBS and set the transmission there. So 1080p 60, that would be the second box. The first one is your base canvas, so whatever your monitor resolution is, or whatever base canvas you want it to be. But that second box there and the frames per second, that's what's going to get sent to the second computer, and that's what you're going to want to basically set the second computer to stream onto Twitch or YouTube or wherever. But make sure you set this part up first to what you want to stream at, and then you can enable teleport. But here we go. Now, to enable teleport, let's go ahead and start that. We're going to press teleport. You're going to give it an identifier. That's naming the PC, so I'm going to gaming PC, and then leave the rest alone. Now, quality is something you're going to want to play with. I like around, let's say, 60% quality, because the higher you bring this up, the more bandwidth it's going to use, and that can use no problem, because if you don't have a lot of network bandwidth, you're trying to do some Wi-Fi, and I'm talking about just your local network, right? The speed from your computer to your switch. That's it, not your internet speed. Most networks are gigabit speed, and it should go to hell. That's just fine. So just start at 60% here, see how you like it, go up and down, see how it sets your ping or download speeds or anything like that. So now with these configured, press the checkbox, teleport enable, press OK, and then we go over to the second PC, the streaming PC. So here we are at the desktop of the streaming PC. This is the second PC that you would have in your setup. Go ahead and read the steps to install the OBS teleport plugin, which I've already gone ahead and done. Then you go ahead and open OBS Studio. With OBS Studio open, you just go down here and add that as a source. Like, let's double check that teleport is installed. There it is. Tools, teleport, that's how you know. But we're not enabling teleport for the second PC. This is what we receive from the teleport from the first PC. So to do that,
So this is the main?
teleport in the sources, you see that there. And then the other one, the first, the source name, we're going to call it teleport. And then allow access, so it has access to your network. When I click refresh list, this we're going to see gaming PC, the name that we gave to the main PC pop up. You click that, and there it is, right there in the drop down, gaming PC.
Wow.
Address, and you saw how I had to start your stream up on it over there. Now you see it over here, and whatever video output settings is configured in that computer will be reflected here. So this
Bro, that is freaking hype.
and so you can just resize that to fit your canvas, or in your case, just give it the same exact settings in here. This is 16:900, 16:900 for the scaling app.
Dude, that is so...
Twitch and stuff like that, especially for Twitch, because 1080p 60 not enough bitrate. But speaking to that point, you have to set up your Twitch streaming stuff, or your Instagram, whatever you're streaming to, on this computer. So you click output, go into advanced. This is where you set up your bitrates. What I like to do for Twitch is whatever GPU core you have, give it about 7,000 kilobits per second bitrate. Keyframe output 2. Set max volume for video. Max keyframe is 2 as well, and that's good.
Dude, he knows all those settings? That's insane. Yo, OBS teleport sounds awesome. Okay, we're gonna do that later. I would love to get that to work. That would be so sick. Okay, so I'm just gonna go solder the magnetic encoders, and then we're gonna mount them to the bottom of this thing. Okay, so then I'll take it apart. So all I need is my wire. Unfortunately, I don't have OBS teleport set up, so wait, but which one do I want to be the master? I want this laptop to be the master. So then what I would do, I'd have to walk over there, turn on the PC, open up OBS, and what did he do? Oh, I closed the tab. But I don't know if I don't think he clicked start streaming. I think he just made sure that it was enabled. So now it's like going. And then I'd have to walk back out here, change the scene to be the teleport scene. But I could probably do that remotely with a WebSocket thing. Like, I never set up OBS Blade. I think I have OBS Blade. Is there a password? I don't think so. Could not find it. Yeah, let's, oh wait, there's a QR. Could not connect to a WebSocket. Hold on, let me go try it again. Why isn't it working? Oh wait. Nice. That's so sick. So then I would just have a scene. Should I try this, dude? I'll try it. Okay, I'll try it after. But OBS teleport seems sweet. This is so cool. OBS Blade, man. First time I'm actually using it. Okay, enough lollygagging though. Okay. I'll be back. Okay. Finally. Two of the magnetic encoders with a big long wire sticking out of them. That's just egregious. Okay, that's a little better. So now, oh yeah, and then whatever. That's not gonna short. Okay, so now we need our breadboard. And the first thing we're gonna do is we're gonna take apart flywheel. See, this doesn't work. Whatever. Okay. So we're gonna take this apart after. We're just gonna hook this up. So 3 volts. Ground. Then pin. I forget. Data I think is on 6, and clock is on 7. Let's look up the pinout though, just to be sure. Data is 6 and clock is 7. Okay, that's good. Let's get my... Okay, and then we can take this. Alright, so now the Pico is connected. So now we just need to go and run this code. Oh wait, did I disable it? Is Thani open? Okay, wait, let's just run this. Okay, so it's getting things. So now that's great. Now we can disassemble this, which means, oh, did I bring the vise? Okay. Okay, now this one. Okay. Do we actually need to... We don't actually need to do that. So I'm just gonna... Yeah. Okay, what we need though is a Allen wrench. We just need to take these guys off. Okay, now on this side. Oh, this one was loose, man. I feel like with so much vibration, it's very easy to get this stuff to come loose when it's so... It's also possible I just didn't tighten it down, really. Okay, so now this is taken apart. So now that we have one of these, we're going to run that code again. We're just going to see if it picks up a reading. Ah. Let's run it. Okay, cool. So that's getting a reading. So now, yeah, we are going to need to cut these things off, or at least bend them down so that they're lower than the profile of the bolt, or the nut that's going to go. Okay, I think that should be good. So now, we need to take this off, because this one's definitely fried. Where's my Allen wrench? Allen, can you hear me? Where are you? There we go. Okay. Okay. Okay, so this one's bad. So now what we want to do is we need to take this out and we need to feed it through. So we need to take these cables and feed them down under, and then it needs to go like that. Okay. So now we need to put this here. And then this actually doesn't need to be all that strong. The main thing is that it just needs to be pulled down enough. But it's like, I don't know, realistically, well, who knows? I feel like all bets are kind of off because I've never dealt with something that vibrates this much. Like, it really is going to knock things loose. Anyways, let's tighten it. Just fully turning in there. I love these vise pliers. These things are great. Why is this raised? Maybe that's enough. Yeah, well, let's put another one in. Push it down. Flip it, we flip it, we flip it. Okay. Fuck. Ay, ay, ay. Is it on there? Yeah, okay. So now I'm gonna need like a half turn more. Okay, so I take my vise pliers, and now that that's locked in place, I can tighten this to my heart's content. And it will pull it close to the... Great. Okay, shouldn't be a problem. So now we want to install the second one. I want to make sure I do it in the same way. So, hold on. Oh wait, maybe we want to cut off some of these. These ones aren't so bad, actually. Okay. Okay, VCC and out are like that. Now we need more M3 by, I think it was 16, and M3 nuts. I need 2 of these. Wait, is that right? No. These are, they're probably M8s. M3 by 8. The 16 is for the other thing. Okay, so wait, is it 8 or 12? Oops. Pull this through. Oh yeah, no, this is definitely right. It's definitely 8. Okay. Dang, it's so easy to like overshoot. I don't actually understand how these are. Oh, there's just a really strong spring in there. Okay. We want this to be back. This should be good enough. Okay. So now we just vice that shit up. Turn it over. Tighten it in place. Okay. So now we have both of these encoders. Now we need to remount these. You know, I want to check. One of these fell out. Oh, I need the screwdriver. Alright. And honestly, I could go for a slightly bigger screwdriver. Okay, they all seem tight. So now, this is going to go like this. Okay. I need more nuts. NMN. Need more nuts. Squirrel mentality be like NM N NMN. Not M&M. NMN. MNN. Oh, wait, MN NMN. NMN. Need more nuts, bro. And here we're going to want to do the same thing with the vise. And this one we actually care about being really tight on there, because if this falls loose, this whole motor is going to fly off of this thing. So let's get the vise clamped down on there. And then where's our Allen? Oh yeah, and this one's kind of annoying, because you have to do the, you don't have a full, but that's okay. Okay, that's really on there. It's not going anywhere for a while. Whoa. Where did it go? Okay, so we're still tightening this nut here. Okay, that's good. Alright, so wait, so before I go any further, I want to get one of these working. So we don't actually need the ESC for right now, but I'm not going to unplug it because I don't really want to. So it's just power, data, clock, ground. Okay, let's run this thing again. Okay, look at that. Working as expected. Okay. That's awesome. So now what we need is we just need one pin. We don't have purple, we have blue. Okay. Or we could have made it white. Whatever. This is going to go to any of the PWM signals. So we're going to make this, whatever, at the bottom here, which I think is like 16 or 17. No, it's like 15. So it's 20. Okay. Yep, perfect. And that's all we need. Oh, I guess we want a ground. We want common ground. So that's fine. So let's just do that. I think I may be like overly obsessed with common ground, but I feel like everything needs to have the same ground. Otherwise, I just don't know what's going on. So then, yeah, let's ground this thing. But then we just don't need the power. We just don't need VCC. Okay, so there we go. We have data and ground, and then we have the encoder hooked up. Now what we need to do is mess with the power supply. Let's install this other one. I'm going to push this back a little bit so we have a little bit more room to work. Okay, so now plug this. What's the next I2C thing? Oh wow, we have a lot of I2C. I wonder if the address is hard-coded. If the address is hard-coded, we're kind of screwed, right? Because I think that this... Oh no. Well, we only need one. Let's do yeah. We only really need one. I mean, that's not true. Like, that's definitely not true, but for right now, we only need one. So this is on tight, this is on tight, sensor's on tight, and it's recording properly. Now all we need to do is hook up this 12-volt power supply. So I need my screwdriver, and I'm going to take out this, and I believe, let's see, there are 4, wait, this must have come out, or I don't know what's going on there. But so let's screw this. Oops. Actually, we don't need to unscrew that. We actually want to keep that one. Oh shit, what came out anyways? Okay. We just need to take these out. Alright, so now this is free. This is basically the stepper control and the old DC motor control. So now we don't need this. We're going to take out the 12 volts from here. Okay, but what we do need is we need this ground to come to here. Which means that, yep, so that means that ground is shared in many ways. Because my computer, oh wait, actually, my computer does not have its power does not have a third prong on it. So that's not tied to ground, but this is going to be tied to ground. This breadboard is tied to ground, which is this, and then this is going to be directly hooked up to that. So let's just do that. So we need one of these. So this is an XT60 connector. They are able to handle very high current. So pretty cool. Twist it, twist it, twist it, twist it, twist it. Okay, we're only going to do one for now. And then I'm going to hook this up to a kilowatt and we can just see. Because yesterday, oh yeah, and I need to mount this actually. I need to go find a piece of wood and mount this to something heavy. Because I cannot, it's scary holding this thing. I mean, it's literally about to take flight. It's going to like lift off into the air. If these were propellers as opposed to, okay. So now this needs to go into COM. Okay, so now we have okay, so now we should be able to power this thing on. So let's that's so annoying though. I didn't realize about the fixed address. I think there's also a way of getting the magnitude. Okay, so I'm gonna go look for a piece of wood and then like, I don't know how we're gonna do this. Could bolt it down, but then it's not gonna lie flat. I could just counterbore that. Ay, ay, ay. Well, for right now, speed, 20% throttle is like not that bad. So what I'm gonna do is first we're gonna close this because I'm pretty sure that this is identical to what? Okay. Oh, geez. Okay. So I'm pretty sure that this is right. So wait, so now we need to do, so we're not gonna run that because that's too much for me. But we are gonna run is bldc, and then this, yeah, so we're gonna run this. We're gonna enable micro pico. We're gonna do connect. Okay, then we're gonna run this code. Okay, so now set throttle is defined. So if I do set throttle, it's a function. But the problem is pin 15, is that right? That is right, huh? Okay, sweet. So all we need is, so power's hooked up, grounds are hooked up, magnetic encoder's hooked up. We just need to plug in this, and I'm going to plug it in with a kilowatt. Okay. Okay, and then we have this surge strip. So we have a kill switch in case anything goes a little haywire. But I don't think anything should go haywire. So we're going to turn this on. Okay, the power's up. Oh, and we're getting our beep, which is great. So now we want to do set throttle of 20. Okay, something's wrong. So it's depower. So, so then what was going wrong with just a normal set throttle? Oh wait, isn't there that weird reset thing? Okay, we're gonna reset. We're gonna, yeah, we have to wait for the stop. And we're gonna comment all this out. Okay, cool. We're gonna do a soft reset done. Now we run this. Now this is gonna be, ESC2 is a thing. And set throttle. Throttle? Whoa. Okay. Interesting. Okay. Now we want to run okay, that's pretty slow. So now we want to run this. Is it just this? We need to, okay. So why isn't this working? I forgot to respond to that guy. ESC isn't defined. That's okay. Okay, interrupted. There's just no way that I could have burned this thing out. It's connected to 3 volts. So let's run this thing. You've got to be kidding me. Did I really burn this thing out? Is it from it touching? Can't tell. I can't tell if it's touching it. No, it's definitely not. So then what is going wrong? Why did this stop working when I installed this thing? If I turn off the power supply, I reset this thing, I run this. Oh, what? I'm so confused. All right, what if I'm going to unplug all 4 of these. I'm going to try the other one. I really hope I didn't burn this out, man. Because I already did it to 2 of them. Ground, 3 volts. Clock, and data. Let's try it again. Okay, so that's actually a good sign to me. But I don't know why. What? What does that actually mean? Wait, let's just try to unplug everything else from... Okay, now we're back to what we had like a minute ago. I'm like positive the pinout is right. 6 is data. 7 is clock. Bro, I'm so confused. What the hell? Wait, let's just try a different address for right now, maybe? I don't think that's going to help, though. So we go down to, what is it? 11 and 12. So this is going to be 8 and 9. No, you run this. Yeah, so... Okay. I'm just going to close. Please work. What is that? These are my last 2. What does EIO mean? Oh, this... Wait. Wait, what's PYB? This seems old. Delay after write? Wait, but it fails on get and reg. Maybe it's because this needs to... I don't think so, though. Oh yeah, you're not gonna be able to get that. Let's make sure that we're actually getting 3 volts, because maybe this thing isn't powered, but that wouldn't make any sense. So that means I need to go get a freaking voltmeter. I just don't really get what changed. It's really annoying. Okay. 3 volts. 3.3 volts. Do we have Wait, so that's actually a good thing. It sees the device. No way. Wait, no, but I just tried that one. Okay, 15 and 14. What? Data 14. Am I crazy? Fine, let's try 16 and 17. Okay, I don't think it's that because it was working. Wait, did I change that frequency thing? Because my frequency is really high. Freak equals 40,000? So what's going on in this code? So scan. Can we? Is this a thing? What? Oh. Well, we should definitely be using this instead of just read from, but who cares? Knack? Is it 56? I think it's 54. Is that? pasting just doesn't work. Okay, that's a good idea. Oh, that's weird. Dude, why didn't I try that? Sometimes I'm just so dumb. Okay, so let's switch. Wait, and if I run it again, does it start failing? Yeah, there's something weird there. Okay. Power cycling. That was what did it. Okay. So wait, let's reset it and we're going to run it again. Okay. Okay, so now I'm going to unplug this one. And I'm plug back in the other one. Power. Ground. And we're going to go back to the other addresses because now I know that there's just something weird about resetting the device. Okay, so we're going to go back to, was it 5 and 4? And we're going to run. And then now we get EIO. So now I'm going to... Okay, great. So now, wait, if I run it again, it stops working. So what I want to do is copy this, comment all that out, paste this in here. All right, let's okay, so we're going to take this. Okay, but we're going to comment this out. And we're just going to do set throttle of 20. Then we're going to go here, we're going to copy this, put this code in here, move this stuff to the top. Okay. Wait. Oh, okay. Okay, I'm just going to do this again. Okay. Um, What the hell is a time tuple? Okay, I don't care. Okay, so we're going to turn on the power supply. Oh, wait, nothing's been hooked up. Oh, yeah, everything's been hooked up. What am I talking about? Okay. Except for this, which is the... What pin are we doing? We're doing that on 15. Okay. What happens? Do we have to, like, wait or something? Just gonna disconnect it. Connect it up again. Wait, we turn this thing on. Now it's ready to go. Now unplug this. Plug it in. Now we're gonna wait. That's interesting. Why does it still say it's running though? No way. What the hell? Bro, how did that fall off? This is why I don't mess with any of this off-brand nonsense. I mean, it's like completely... All the prints are totally... Look at this. Just terrible. I rarely have a problem with the freaking good filament. Okay, so this is still ready to print. Ay, ay, ay. That sucks. That sets me back so much. Okay. So now we're going to do connect. Now we're going to run this thing. So why is that? Okay, we're going to... Okay, so now it's ready. Now we're just going to run... We're going to comment this out. Wait, no, not this. We're going to comment this out. We're going to run this file. And then we're going to set throttle to 20. Yeah, so why is this happening? If I just do... Okay, wait, let's... Okay. Power supply on. Oh, you know what? I know why. It's because we have a floating ground here. Yeah, I took this off to sample the Okay, this will definitely fix it. Yeah, you need a common ground. Bro, why is it always grounding issues? It's always, you just gotta stay grounded, bro. You just gotta stay grounded. Okay. So wait, we're gonna... Beep. Okay, slow beep. Now we run. No. Dude, what could it be? I mean, this thing was just freaking working, man. Okay, wait, let's just make sure that this is still working, just because I'm so paranoid now. Sick. Okay, everything is off. We unplug this. I'm going to turn on the power supply. I'm going to plug this in. It should start beeping slowly. but it's not. Okay, good. But it's not. That's no good. That's new. Okay. This is really, really... I must be doing something so obviously stupid. Fantastic. If I close this, I probably get... It probably releases. Nice. Please work, man. Yeah, so for some reason you can't start it at 20. Okay, but now we want to run this. Oh, hell. Okay. So I don't really know what changed, to be honest. So we need to, so we need to set throttle to 30, sleep for a second, then set throttle to 20. So it needs to ramp down. And then, okay. All right, what do I do? What the hell do I do? I unplug this, power it off, power the thing on. Please give me slow beep. Slow beep. Nice. Okay, we have slow beep. Now we run this. I don't understand. What changed? Maybe I have to sleep after I do this. I don't really know. Okay, so we got slow beep. Okay, that I don't understand. Like, why is it... Okay, let's just make sure that we can reliably... Whoa. Okay, so let's just see if we can reliably get... Yeah, what I don't understand is, what does this file do? I mean, it defines the thing, and then it just immediately sets the throttle. So okay, if I do this and just run this script, this fails, right? Oh my god. This is driving me insane. I don't really understand. Okay, everything is turned off. So now I'm gonna plug in the Pico. Then I'm gonna turn on the power supply. We get our slow beep. And then I'm gonna comment this out, and I'm gonna run this file. Then I set throttle to 30. That's so bizarre. I feel like if I do that in Thonny. Okay, so wait. I want Thonny. Do I have to close this? Okay, just for my sanity, I feel like there's something weird going on. So I'm gonna plug in the Pico, go over to Thonny, click stop, and now we're in here. Now I'm gonna turn on this thing, and of course Control comma doesn't do anything, so I'm just gonna delete this. This editor sucks, man. Okay, so I'm just gonna run this code. No, okay, we get the same thing, which is actually nice. Okay, let me actually read the freaking documentation for this thing. E203950. No, that's just the fly color. Maybe AliExpress has the documentation. This manual sucks. This is what I got, but at least we found that. So I'm gonna add that to the part docs. Okay, so what does that mean? You need to calibrate throttle range? Oh, you know what? What if I try... Okay, wait. Turn on the transmitter. Move the throttle stick to the bottom position. Connect the ESC... Okay. Connect ESC with battery and wait for 2 seconds. Okay, so we're gonna. Okay, so we're gonna. Okay, so I want to do a, because that would be the only difference, is that this code, since it starts at throttle 0, it basically is this normal, because it waits for 2 seconds. Dude, that's a crazy coincidence. Wait for 1 second, it means no brake. Okay, so let's just try this. So we're going to do set throttle to 0, sleep for 3 seconds, then we're going to set it to 20. Or let's do 30. Okay, so wait, I'm going to actually comment this out. And I'm just going to run this. So we're going to stop. Okay, we're going to run this every time, bro. I'm addicted to these throts. Okay, so now it's running. It's run this code. I'm going to turn this on. Okay. Beep, beep. When motor emits a long tone, it means brake is available. ESC is ready for working now. So now I should just be able to say set throttle to 20. Okay, so it is probably working, but it's too low. Okay. All right. Wow, that was a crazy debugging thing. Okay. So, awesome. That was very satisfying for me. So wait, so let's open up VS Code again. Okay. So in here, in angle with throttle, all we need to do is first we set this to 0, and we sleep for 3 seconds. Then we set this to 25, and then we set this to 20 after a second. And we, actually, I wonder if we can go lower. Let's see if we can go to 10. Okay, so, all right. I think we're ready. I'm going to copy this into this. Okay, so we're going to run this, and then we're going to run this one, because I want to turn on the power supply at the right time. Okay, so we're going to run this code. So we're going to do a connect. What? Oh, yeah. Okay, so we're connected. Now we're going to run this file. The power supply off. We're going to run it. Now when we turn this on, it should go beep, 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 and then beep, beep. Hey, awesome. And then the next thing we need to do is just run okay, let's do okay, so this is going to be this code. So we're going to just run this. Okay, so 10 is too low. Let's set it to 15. We can now... I think 20... I think it could be a... Okay, now we are finally ready. It does seem like it'll be able to... Because it's getting... Okay, so let's turn this off. And then let's... Oh, wait. We have to go to the top of this before it was turning off. Okay, so let's see this crossing. We want this to be 355 to 0. So let's do this to here. So we're going to copy this. Okay, so we had 26 samples. Per revolution. So wait, now I want to read the RPM code. Okay, so this is all the same stuff. Initialize previous angle, previous time. Wait, you can't do this. That's not going to work. Okay, so you get the angle and you get the time. Ticks diff. Is this an official function? Oh wait, that's a... Oh, it is. Is that a real thing? Let's read some documentation. Micro Python time. So, ticks diff. Okay, sick. That's awesome. I wonder if you could actually select MicroPython and get that, but I'm not going to worry about that for right now. Okay, so then, then delta angle. Oh, it's going from, okay, that's, wait, I don't think that's going to work, right? Let's try it. Let's try it. So what we're going to do is we are going to do this, then this, and then rpm.py. And then we just need to make sure that these pins are right, which they are. So we're going to run this. Okay. We're going to turn this on. Beep, 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 beep. Oh, wait, no. Okay, we need to disconnect. Okay. Okay, run. Hello. Okay, there we go. Now we go. Perfect. Now we need to run this. Okay, now we need to run this. Divide by 0. Wait, can't I just do ticks and s? If you need higher precision, absolute time, use time ns. What's the difference between ticks ns and time ns? Oh yeah, no, we want ticks ns. Okay, so or us. there's no way that that's going to be... Okay, so we need to do this all over again. So we unplug, plug it back in, run this code, and let's just, to save myself some time, we're just going to run this, turn on the, oh wait, yeah, turn on this power, no wait, I think we can just do this. Okay. A lot of variance in this thing. But we want to do, there's a number of things that we want to do. First off, we want to make this a buffer, read from into, because that will save. Plus, I think that this is allocating this, so wait, presumably, okay, we should probably do the test. So let me add to my to-do list, as a sub thing, is that, test if, I can sample faster with Arduino. Because if loops in MicroPython, just the interpreter speed is the bottleneck there, then that might be no good. Okay, so what do we want to do is, I mean, let's just take these whole readings. Oops. I'm going to copy this into Okay, we're gonna just parse this. I'm just gonna use Julia. Okay. Wait. Wait. How? What? Oh, it's so. What a terrible error message, dude. I mean, I get that this is like how Julia works, but okay. Okay. Do we have a stats based thing to just? What the hell? Wait, this is RPM, so divided by 60, 50 times a second. Okay, so let's run this, and we're gonna do let's do 40%. I don't know if it's gonna be linear. Well, let's do 30%. We're gonna clear all this, or I think it should be cleared if I do this. Okay, well, we'll just make it run for. Okay, so we can just turn this on. We can just run this. Oh shit! Wait. Oh no. Okay, my data's all fucked. For some reason, I can't stop this thing. Okay, what I gotta do is I gotta unplug it. Let's see, do we get any samples? Probably not, right? Yeah. It fills up super fast, actually. I forgot. I need to be wearing safety goggles in case this thing explodes. Okay, so let's just do the test again. This thing goes so fast, though. Okay, so what we gotta do is we gotta plug this in, run this code. Well, you can turn on the power supply. Oh, wait, what happened? For some reason, this thing does this. I don't get why it... Yeah, it's not gonna work until I do this. Okay. Now we turn on this and we run this thing. Oh wait, I want to bolt this down so that I don't have to hold it. So let me go look for something to do that with. Found this thing. This thing might be good. The only issue is now we got to oops. We got to move everything. Bro, I just got a comment on YouTube. Why do you remind me of Michael Reeves? Bro, that's like such a nice compliment. Michael Reeves is such a goat that like I feel like, oh yeah, so we're gonna need the USB to come over here. That's okay. I think it'll work. So first let's disconnect this. And then let's bring all three of these things out and over here. Okay, so now we're gonna need to bolt this thing down so that it's not a risk. I feel like I could just use self-tapping screws as opposed to a bolt. Because if it's embedded in the wood, then it's going to hold it down. So I'm just going to get a screwdriver and some normal wood screws or whatever. And then, yeah, I'm just going to do that. Okay, so what I got is this, a screwdriver. You even see the platform, whatever. We're just going to do this. Oh, this bit doesn't work. Yeah, this is a bad bit. I need to get Okay. So we got a bunch of bits. Okay. Much better. Oh yeah, that's not going anywhere, man. Whatever, 2 is good enough. Yeah, this thing is gonna be fine. Okay, so that's great. That's huge improvement to my quality of life. So now, okay, so let's keep freaking going. So now we just gotta get this USB cable. Switch these. Switch this to this. Oh yeah, we are gonna be disconnecting and connecting this thing a whole bunch of times. So it's good that it's gonna be over here. Like that. Okay, is the power supply on? Oh my goggles. Okay. Beep. Alright, where are we at with this? So now what are we testing now that it's bolted down? Oh yeah, we're running this, okay, so we're running this code. And it's gonna turn on. Okay, I absolutely lied. We are definitely gonna need to take and screw it all down. The vibration is insane. Okay, so we just pop that bad boy off. Where's my screwdriver? Okay. Oh. Okay. Should be better now. You are better now. Better now. Not around. Not around. What song is that? Better now. Better now. Oh yeah, it's Post Malone. I like Post Malone, man. Not around. Not around. Everything. Oh wait. Okay, so if we look at this, so if we look at these readings, the RPM is fluctuating between 20,000. You know, it's all over the place. Actually, if we probably parsed and took them, let's just do that. And we go to RPM. What is this? 30%. Okay. That's probably enough samples. If we were to do this, well, whatever. Okay, if we were to do, if we were to take the mean of this, is lower. It's closer to 0 than the other one, which means to me, that maybe we need to be a little bit smarter. I'm going to run this code and see. I mean, because let's say two subsequent readings both give 0. You really don't know if it went all the way around, it didn't move at all, or it moved more than once. So you definitely need more than one sample per revolution. And I feel like there's I think that's related to that like Nyquist sampling limit or something. But so what we're gonna do is we're gonna run this again. So we're gonna turn on the power supply. Oh wait, we probably have to do, yeah, we probably have to do this. Okay, then we run this on. And then we run this. Oh my god. Bro, why do I always forget to mute? Or unmute? I'm so dumb. I just had like such a good explanation of all this stuff. Whatever. So what do we want to look up? We want to look up, we want to ask, I need to do this reading from the as fast as possible because the motors that I'm sensing the RPM from is going to be pretty high. Is there any reason to expect that if I moved from MicroPython to Arduino, that I would see a significant speed increase? No, that sleep is... What an idiot. That is the default. Oh, wait. Why is that... Dude, the transcription is so stupid. What is Viper? This doesn't even... Oh yeah, wait, we forgot to do that. Okay, wait, hold on. So it's two bytes. So so wait, let's go to the I2C MicroPython. Read from into adder buff. Okay, wait. So we need to... Okay, so so the first thing is... Yeah, I mean, I don't mind just writing the assembly code. That seems fine, actually. Okay, so first off, can you help me adapt this code into something that tells me how many samples a second I can get? Wait, read from into... Oh, it's gonna... Okay, so you don't have to provide an N. Okay, that's cool. Okay. All right, so And remember, we're doing this. Is this gonna work? I think I might have to restart it. Yeah, okay, that's okay. It's 2,600 samples per second. That's low. That's low, right? Because if we're moving at... Wait. No, wait, that's not right. Seriously? That means we could go crazy high RPMs. That doesn't sound right. Let me switch this to, instead of a buff, we're gonna do this this slow thing. We're just gonna do this. Read from... No, see, that's not... Wait, but we're printing them. Dude, that's why. Okay, what happens if we try to sample this? This is gonna slow it down significantly. It's all IO bound. Yeah. I mean, that's definitely making it slower. So what do we need to do then? Is we need an online algorithm, basically. It needs to run live. Okay, so, all right, so what do we need to do then? That means that we need to... we want a running algorithm that remembers its last and its current. I think that's what the RPM does. So wait, maybe we can just modify RPM to... I mean, we didn't see any change, but, you know. Wait, what was the... I'm so bad at this. Yeah, you just read into the buff. Because then that mutates it. So what are we doing? We're going to the RPM file. We have a buff. We read into the buff. We don't need... This doesn't return anything. We just return the buff. And we don't need n, but whatever. Okay, so we don't print this. Will this work? I actually have no idea. Adjust angle for wraparound. Well, let's just run it. Oh. I can't interrupt it. I think it's just some of the bullshit. Okay. That's fast. Samples, is that true, dude? I feel like there's no way I'm sampling that fast. 2,000 times a second? Okay, let's just do some mental math. If, let's say it's moving at 10,000 RPM. Okay, all right, 10,000. This is how many times a second it's going. So so that means times 360. This is how many degrees per second. Okay. Now, if we're doing, wait, hold on. I need a pen and paper. I'm gonna go get my notebook. Damn, I stay taking fat L's, man. Look at what was inside my printer. Oh, God. I don't know what I'm going to do, man. That was with the good filament, too. There's got to be something weird in the... And then the... Oh, God. That's such a fat L, dude. All right, so we just want to calculate the what we want to calculate is where's my pen? Is basically samples per second is equal to 2600. Okay, and if the RPS is equal to 166, then that means that the samples per revolution is equal to so then we should get 2600 over 166. 15 samples is equal to 15 samples a second. Wait, that actually checks out. Or wait, no, sorry, per revolution. Because if we go to foo.txt, when we counted, what was it? It was like, wait, was this the slow part of it? Oh, wait, no, we just selected, this is 26. And that was at way less than 10,000 RPM. Okay, so that's sort of the, oh, hilarious. Whoa. So we should actually, if the 2600 samples a second is legit, then 52,000 should be the revolutions per minute that we're sort of capped at if we want 3 samples per revolution. Let's see. I want to ask, how many samples per revolution should I need to get an accurate estimation of RPM? The number of samples... $20? So what's 260 times 60? Okay. Okay. Oh man, I'm so bummed about this freaking printer. It wasn't even extruding when I was watching it. I need some water. Okay, we'll get back to testing. $10 per. Okay, so. All right, so we need to run RPM, but we want to rewrite it so that. Okay. The But was that giving me negative readings? Shouldn't matter. Oh, yeah. I mean, we are sort of pretty frequently getting this 2600 number, which is nice. I mean, that's good. That means we should be able to go up to RPM detection of, well, 10,000. Okay, let's turn on the power supply. Let's run this code. Oh, is that going to work? No, yeah, probably not. But that's based on one reading. Oh, wait, this is also wrong. This printer thing is going to be a cloud over my head. Whatever. There's lots of problems, so we're just gonna have to move forward. Wait, why is it 6? Oh. Okay. Wait, then this number was super off. Okay. Okay, so this is clearly wrong. Um, yeah, okay, that makes sense. So you get the angle, you get the time, and you store it in the buffer basically. I don't really get why it's this. Is this not gonna work? Hello? Okay. What the hell? Wait, that's not a good sign. Okay, fucking whatever. Okay. Oh. Oh, that's so weird. Bro, I didn't know about that. That's such a goofy syntax. The list 0 times 3 makes a list of 3 zeros? Who, what? That's so silly. But fine. Okay, then you. This is a B minus A thing. So, okay, so let's say you have 340, or you have 20 and comma 340 as the two readings. So then you get 340 minus 20, 320. Because this is going the wrong way, sort of. If we just do this, it might work. Because now we get 20 minus 340 is equal to minus 320. No, can I just write my own diff function? This is so stupid. Okay. I know this is kind of goofy, but if... No. If angle... Oh, yeah. If this is greater than... Then... Wait, is it? Just because of the way it's spinning, right? Because it's counting down. So if it's counting down, I think it goes like 80 to 40, then you want, yeah. So this is right. So let's try to run this again. So we're going to do this, run this code, turn this on. Okay. Then we're going to run this. Now that seems like good readings. That seems like pretty accurate reading. So it's about 3,200 RPM. So let's just do the calculation that okay, so we're going to do this to 25. And basically we just want to see if there's a, we need to do some real statistics. I didn't actually, I didn't copy that thing and it's, oh wait, here we go. So this is at 20%. These are the readings for 20%. Let's just get them all. RPM 20%. Oh, really? Wait, what were we getting before? Alright, so this is a lot smoother. And this was all total garbage. So, we want to just do this thing again, right? We want to run. There's no way this thing is going at 20,000 RPM. I don't even think it's going at 10,000 RPM. The variance is a lot higher. Let's just copy the readings and start to, I mean, I just don't believe this number. Wait. Ah. 50 versus 2,000. The standard deviation is 20 times more. What if we go even slower? What if we go to 21%? Okay. Oh yeah, I messed this up. Shit. Okay, wait. So let me just write down those readings. Oh wait. Okay. Okay, soon we're gonna after this we're gonna write a code that that actually just starts well, writing it to a file will be why does it start doing this? All right, I mean, maybe it is really moving at 10,000 RPM. I think it's just once it gets to that level, it's just unreliable. At least we're starting to get some data. So let's I mean, it does seem like, I mean, 3,000, 4,000, then 5,000. Okay, so wait, let me just let's just do some fun math. Okay, so let's just say it's moving at 6,000 RPM for easy numbers. That means that divide by 60 1 minute, 60 seconds. Then we get 6,000 over 60 is 100 times a second. 100 revolutions per second. Now, the diameter of the flywheel, I think, is around 80 millimeters. So so that means the circumference of the flywheel is going to be 2 pi times 40. It's going to be equal to 80 pi in millimeters. This is the circumference. So now, now we want a meters per second thing. So if it's moving, instead of revolutions, it's going to be 200 pi. Or wait, we don't want radians. We want times 360. 100 revolutions times 360. We want 3,600. No, 36,000 degrees per second. So 36,000 degrees per second. Well, we could do radians. 200 pi per second is in radians per second. So now, okay, I'm just gonna. Oh, okay. So if it takes 0.01 seconds for a revolution, if it takes 0.01 seconds per revolution, then that means that it's traveling 80 pi millimeters in 0.01 seconds. So that means that it's going to be 8,000 pi millimeters. So that means 8 pi meters per second. 8 pi? What is 8 pi? 25 meters per second. Let me double check my work. 25 meters per second. That's not that fast. I was hoping for 50, man. Okay. If my flywheel has a diameter of 80 millimeters and the flywheel, or in the shaft is rotating at 6,000 RPM. What is the tangential velocity? Haha! Yes! Okay, I'm not an idiot. I got it right. I actually did math. So it is. So it's moving at 20. So is that fast? I can't tell if that's fast. Let's hook up the other one and then yeah, I want to hook up the other one and get this thing popping. I want to shoot this thing now. Should I? All right, we'll just do some tests. I'm gonna get a camera so that I can. Yeah, I'll go get the camera. Maybe the one from upstairs. Oh, I'm so pissed about my 3D printer, bro. Bamboo needs to send me a carbon. Or no, Formlabs needs to send me some a resin printer, a Form 4. That's what I want. Okay. Okay. Wow, I lost my little mind. Far from the heart, why can't you see the angels are for my darling? Okay, so this is gonna be really annoying because we clamped this thing down. I shouldn't have done that. Let me just take him out. Yeah, let me just take him out. The angels sing for it, my baby, my darling. Oh, it's spinning in there? That's no good. It's pretty stuck in there. That's perfect. I'm just gonna get on the ground and do it. Oh, this is gonna be a nightmare. Nightmare, nightmare, nightmare. Wait. Oh no, it's yeah. Okay. Okay. Now we just gotta get the vise on there. Oh, and now I need the Allen wrench. Where the hell is the Allen wrench? Is it over here? Okay. Now we just gotta okay, wait. We're just gonna do it from here. Nice. Nice, nice, nice. Okay. Okay. Here, I'll show you guys what it looks like in a second. I'm gonna go get a camera. We need it to be higher up. We need it to be like here. Okay. This will probably fall off. Because of how much this is on it. Okay. So Oh yeah, and then lol. Okay. Jeez, my fat fucking body. All right. So let's just put this here for now. Okay, so what we need to do is we need to take the second ESC and we need to plug it into the power supply. Now I have my connector for that here. So this connector goes into the ESC. I like how you can't mess up the directionality. That's quite nice. It's a good feature to have. Okay, now I need my screwdriver. How did I fuck this up so much? Let's just do this. Okay. Okay. Screwdriver. Let's make sure that we get the wires somewhat neat. Right. Okay, it's just not going to be neat. Let's plug these in. So I'm pretty sure it's 10 and 11 for the pinout. So pin out. 8 is data. 8 is but we can just use 9 and 10. 9. And plus minus. Okay, so now the oh wait, but we don't want to actually. We're not even going to use that. I'll keep it plugged in, but we're not going to use that because I think that you can't, because the I2C address is fixed. I mean, I don't really know the protocol, but I think that there's something there that you can't only use one of them. But in any case, we need now the signal. We need another PWM signal. So we'll use 14 for that. And we'll make it blue as well. Oh, sheesh. Okay. So, oh, and we need a ground. Okay, so this is going to go to... Wait, let me check my stream preview to see if you can actually see it. Okay. Here. And then... we just need ground. Okay. Ground. Okay, so that's all hooked up. Now we just need to hook up the power supply. Make sure it's off. Yeah, okay. Flip this thing up, unscrew this. Okay. Sweet. And then the last melon. Okay, that should be good. So everything is wired up. Oh, except for this fell out. Okay, so what we're going to do is we're going to go to the code, bldc, and we are going to enable, oops, 2 of these, and we're just going to have them set to the same thing for now. So then, and let's get it down to 20, and we're going to try to turn this thing on. So we are going to turn on the power supply. Oh, wait. No, yeah. Okay, now are they spinning in opposite directions? Okay, I'm gonna go get more balls. Okay, I got this, and I think I'm ready to record the clip. I'm pretty sure we have room to bring this out to here. Let's see, how does the stream look? Okay. That doesn't seem too bad. And then I'm gonna record one with my phone. And put on a shirt. All right, get my phone out. Okay, all right, so let's do this thing. All right, we want to, we turn off the power supply. We just need to unplug the microcontroller. Plug it back in. And we're going to start off with 30% power because why are we alive if not to do high power shit? And I also, okay, so wait, so we're going to turn on the power supply. I'm going to click run. Okay. Now the current draw is only 1 amp. It's not that good of a video. I need to mount it. Okay. Wait, where did I put the freaking goggles? Okay, I'm gonna disconnect. I want to see what the current draw is. So I'm gonna do a let's see. I'm gonna do the throttle example. So where's the throttle example? Oh, that's this. All right, so we're gonna turn this off. We're gonna turn this on. And I'm just gonna watch the current draw. Whoa. Okay, so honestly, I'm kind of disappointed. Like, I don't know what changed, but when I used the variable power supply that I have inside, I was able to draw 5 amps. But if I run this code, I don't know why it does this. I have to like turn off the power supply. I gotta kill this program. I gotta unplug this thing, plug it back in. Okay. Okay, well, 2 amps. Okay, I don't even know what the RPM should be. But all right, let's do a test. I really want some good footage, though. Um, I have a feeling this box is gonna fall off. What the hell? My VS Code is being weird, bruh. Okay. Connect. Okay, sick. Now we can comment out this. Turn this on. Set this baby to 100. And let's freaking run this thing. Oh my god. It's got to ramp up. It's got to ramp up. Let's do it again. So one of them stalled. I don't know why one of them stalled. Maybe I just can't run it that hot. I mean, they're getting warm. I don't know if I need to cool them. Okay, let's reevaluate my to-do list. Fixed 3D printer. Oh wait, this is not done. Okay, this is done. Just to document okay, so mount the flywheel, we did that. Design the feeder. Yeah, we need to do that. Okay, should I do OBS teleport stuff? That'd be fun. Get my mind off this. I might make some lunch. Maybe we could start playing with some paint. That'd be fun. This paint is gonna get everywhere though. Ay, ay, ay. The next thing that I want to do kind of is, well, the feeder is really important, but I want to know for a given compression distance between the flywheels, how far does it go? Like, Like, okay, you're looking at this. You want to. Okay, so you're looking at the flywheel like this. And you see how it sticks in there, kind of? So the amount of compression that needs to happen to launch this guy through. Right now it's 5 millimeters. Actually, this doesn't even look like 5 millimeters, though. Maybe it is. Anyways, at some point I want to actually get a sensor that lets me model based on how much compression, how much force pushback, how much force is required for a given distance of compression, because then I can model the spring accurately and start to do more physics on like what the optimal compression amount is. Ugh, look at how I sit. Let's turn this camera off. I don't like to see that. That's disgusting. Oh god, big back shit. Shit, bruh. Okay. The reality is this thing is just sus to use, man. Like, it's so loud and it's like, I mean, it's still on there pretty strong. So I think our max power shouldn't be 100. But I would say it's reasonable that we're getting somewhere in the realm of 10,000 RPM. If those readings are accurate. If my readings of using the magnetic sensor to determine RPM. So 10,000 over 60. Yeah, right, is 166. So that's per second. So in meters per second, we okay, so that's 40 meters per second. So let's say that something is, let's just do some basic physics. Do you have a paint? Okay, so let's say the ball is going this way at 40 meters a second. Oh, that's a race? Okay. And the height is, let's say it's at, say it's at 1 meter. Jesus. The eraser needs to be bigger than the... Oh, is that this? So then basically we want to know what is the time that it takes for a ball to travel. Well, we want to know, oh, that's undo. Oh, that's weird. So we want to know this distance. Okay, so let me just, now that we've defined the problem, this is the classic physics problem. So its initial velocity, v0, is equal to just, in the x direction is 40 meters a second. v0y is equal to 0 meters a second. Yeah, that's true. But its acceleration is minus 9.8. Okay, so we want to find t. Oh, bro, I forgot all this. I'm gonna just ChatGPT. Help if a ball is launched horizontally at 40 meters a second with no and height of 1 meter, how long and no vertical of velocity, how long will it take to hit the ground? Okay, so yeah, so the equation for the height of y is equal to y is equal to is 0 plus 1/2 . Wait. Oh, there's the 1. This is sort of buried in there, but there's the 1. So end up being the square root of... Okay, so now we want to know the horizontal distance traveled in... $18 meters? Okay, I think we should hop into CAD then. We've done some math. I'm gonna go get a snack. Oh yeah. Oh. All right, yeah, I'm gonna make some food, and then we're gonna tackle this bull crap of. We're gonna finally make a feeder. The problem is I gotta fix this printer, dude. I can't believe print issues is just like the thing you just want the least. I'm so sick of it. Uh, oh yeah. Ay ay ay. I'm gonna get some food. Okay, I'm finally back with some food. Okay. I need to get better with my money. I'ma go from rice to riches. I'm better, bitch. I'm poor when I'm down. Keep your eye on me around. I don't want the shit to fall to the ground. Yeah, diamonds, yeah, they dancing on your bit. Hey, rainbow, I don't know what it is. I know what the words are. Alright, every little thing inside. Mm-hmm, mm-hmm. What the hell? Alright. Dude, I want an FOC controller so bad. My tools, my tools. I need my tools.
What the hell are you doing?
Whoa! Dude, what's all that stuff you're grabbing?
Tools! Tools! Duct tape, zip ties, and gloves. I have to have my tools.
Why do you have a bunch of, like, weird tools in a hidden compartment in your car?
Fetish shit. I like to bind. I like to be bound. It's not important. Don't ask me questions. I'm not taking questions. The golden god is not taking questions. I am the golden god.
Holy fuck, dude. This show is actually so funny.
I'm taking action. I gotta go.
Whoa. Wait a second, Dennis. Wait a second. Oh, I think we can help you, dude.
Yeah?
Yeah, we can help each other. We both want the same thing. Revenge. You're gonna be our new Psycho Pete, pal. And guess what? The freight train's back in service. Let's get nuts in this school. Let's get crazy, all right? Come on, let's get some revenge here.
Train's coming. Watch out for the train. Watch out for the train. The train's coming.
Make way!
Dude, that is so fucking funny, man. Imagine being like on the... Oh, I got copyrighted? Dude, come on. Oh, okay. No, I'm good. I might end the stream and just go try to fix the printer and then set up OBS teleport off stream. Because I don't think you can install a plugin while it's open. I think you have to restart it. Oh, wow. I'm eating noodles, yeah. What's going on, Natasha? What you up to? Coffeeaholic? Bro, I'm so addicted to coffee right now. Iced coffee in the summertime? Crazy, bro. My tools. I need to have my tools. Oh, jeez. It's going great. Find some interesting stream. Here, I'll show you something cool, actually. Let's see. So here's what I've been working on. So this is the electronics. These spin really fast in opposite directions. This is the this is the computer, and that's the power supply. Then I have this, which is a bunch of nerf rounds. You stick one of them in here, and it shoots out the other side. And according to my calculations, it should be going. The ball should travel at about 40 meters per second, which is like decently fast. It's not like super fast. Like, let's see what's a gun's velocity. Let's see. Various different guns bullet velocity in meters per second table. Let's just see what, because these are all going to be really. Okay, so a gun is going. Damn, that's insane. 1,000 meters a second? That's actually insane if you think about it. 1,000 meters a second is so fast. That's like half a mile in a second. Wow, I didn't realize that. So yeah, so it would be. Right, okay. Yeah, air rifles, BB gun, Nerf gun. Right, so we're sort of in the lowest end of this zone at 40. So we're sort of faster than a Nerf gun, slower than a paintball gun. It would be cool to use compressed air, because I feel like compressed air is probably more efficient. Yeah, anyway, so the next step is to design something. Let me see if I have it open, actually. So I was trying to work on this design where I have like a, this thing is going to have like an attachment to it. Then there's going to be Nerf balls like in this channel. And then I'm going to sweep them up into here. And then this is where the flywheels will be. But this is like a new design. And honestly, I'm not that mechanically inclined. So it's very hard for me to visualize how all the things are going to fit together. But this is the hope, is that, because what I need is some mechanism to take the bullets and one by one fire them at a specific time. Do I have a stream daily? No, I don't really have a schedule. I'm trying to stream most days, pretty much. The thing is, I've found, like, trying to stream every day is a little bit too much, because some days I just need to do something, like, I mean, ideally I stream everything, but I don't think it's, like, gonna work out that way. I think I'll probably try to stream, like, 4 or 5 times a week. I mean, yeah, something like that. Let's see, how does a paintball gun work? I've seen this video, but... Okay, wait, so... But is this an automatic one?
This is my air cannon. It launches all kinds of things. Apples, hot dogs, and potatoes through watermelons, to name a few. It can be operated using a blowgun or a solenoid valve, and filled using an air compressor or a high-pressure bike pump.
Bro, that's sick.
Pause the video to look everything over, and I'll leave links to all the parts in the description. Note that to make one. Pause
Sprinkler valve.
the video to look everything over, and I'll leave links to all the parts in the description. Note.
JB Weld, pressure gauge, blowgun.
Even Schedule 40 PVC like we're using.
I could probably make this.
Here is designed for transporting water, not pressurized air. I'm assuming my own risks here, as you need to do as well. Stay safe. First, take your 2-inch pipe and cut pieces for the barrel.
But if you want to get is that true? I have to stream every day? My thing is that, though, I upload all these videos to YouTube, so I get stats from YouTube, and then I post clips on all the things, so... Dang. I mean, why is that? Why do I have to stream every day? Like, isn't affiliate just, I thought affiliate was just, like, you need, like, a certain number of followers and a certain number of watch time. Let me look it up. Yeah, you just need to stream. No, this is within a month. Yeah, you need to maintain an average thing of 3 coherent viewers. You need to stream 7 days in a month. And then a total of 8 hours and have 50 followers. No. That's by month. There's no way that they have you... I'm almost positive this is not... Yeah, look at this. Here. Disproven. Okay, stream on 7 different days. To qualify for the... You must simultaneously meet all 4 requirements over a 30-day period. Yeah, that would be insane if it was 7 days a week for 30 days. No one's meeting that. Yeah, so you don't have to do it daily. You just have to do it 7 times a month. And I'm trying to do it 5 times a week, so I'm pretty good.
And air chamber. You can experiment with the sizing here. My original cannon has a 20-inch barrel and a 30-inch air chamber. Cut 2 2.5-inch pieces from the 1-inch pipe. Deburr each of the cut ends with sandpaper, then loosely assemble all the PVC pieces as shown so you know how they'll fit together. Chamfer the end of the barrel with a file or bench grinder to make it easier to load potatoes and similar objects.
Oh, wow. Oh my god, that's so cool.
Make sure your work area is well ventilated and check the label on your cement for the working and curing temperature ranges. If it's too cold, the cement may not cure properly. Working one joint at a time, prime the two mating surfaces. Allow the primer to dry, then apply cement to both surfaces and assemble the parts. Rotate the joint as you do so, then hold the pieces firmly together for 30 seconds. Wipe away any excess cement and repeat the process for each joint, then set all PVC parts aside to cure. As the cement cures, we can prepare the sprinkler valve. Remove the small plastic knob as well as the solenoid. Unscrew and remove the top piece, which I'll call the lid, being careful of the spring inside when doing so. Cut off the solenoid cavity, leaving about a 1/4 inch of height on the inside. Drill a 7/16 inch hole straight down in the center of the lid. You can easily find the center on the underside of the lid. Use a small drill bit at first and increase the size several times to ensure the hole is straight. Tap the hole, being careful to keep the tap straight up and down when doing so. Turn the tap clockwise 1.5 turns, then counterclockwise 1/2 turn, repeating until the hole is fully tapped. NPT taps are tapered, so stop as soon as the fully threaded section appears at the bottom of the hole. Add 3 wraps of Teflon tape to the male NPT coupler in a clockwise direction, then install it in the lid using a wrench. With the coupler...
What is he using for pressurized air, though?
Valve, making sure the spring is compressed between the diaphragm and the male NPT coupler. And screw them firmly into the sprinkler valve. The valve has an arrow that shows the...
Hold on. Yeah, I'm not really much of a gamer. Sometimes I like to play Civ 5. I've never actually streamed playing video games because I thought, like, so many people play video games. It's like, what am I really adding? Like, I'm not that good at video games, so it's basically you're just watching someone who suck. But this is something that I'm actually, like, okay at, so... Yeah. Do you stream? I didn't see it, but you have a profile. It's crazy because, like, you're like a real person. I feel like there's only one other person that regularly comes to my stream that's like a real person. My boy Olala. He's the GOAT, dude. He's the OG, man. He tunes in. He lives in Poland. Okay, let's see how he pressurizes this tank. What did you stream? I never played it. Where are you based? Natasha's a Russian name. I had a Russian roommate, and her name was Natasha. Okay, I'll come back in a second.
Correct flow direction. The arrow should point away from the air chamber towards the barrel. On the air tank end cap, mark and drill 7/16 inch holes 90 degrees apart for the pressure gauge, fill valve, and the drain valve. Be careful as you break through the inner wall so you don't drill through the opposite side. Note that the sprinkler valve will face downward during use. Make sure to arrange your drill holes appropriately to keep the fittings out of the way. Tap the holes, making sure to go just far enough for the fittings to seat properly. Shake out any loose chips, then add 3 wraps of Teflon tape to the gauge and valves and install them. Orient the gauge's display backwards so it can be easily read during filling. Add 3 wraps of Teflon tape to the exposed end of the male NPT coupler, as well as the end of the blowgun. Add the female NPT coupler to the blowgun, then install both on the male coupler. Point the blowgun towards the barrel and your air cannon is complete. Without loading a projectile, fill the air chamber to see if it has any leaks. Begin with a low pressure such as 20 psi, checking each cemented and taped joint. If you hear a leak and are having trouble determining which joint it's coming from, apply some soapy water and look for bubbles. If a cemented joint is leaking, depressurize the cannon, cut off the fitting, and replace it with a new one. If a tape joint is leaking, depressurize the cannon, unscrew the fitting, replace the tape, and reinstall the fitting. Grab some ear protection, then dry fire the cannon by squeezing the handle. Work your way up in 20 psi increments for safety. The lowest pressure rating of all my components is 160 psi.
Wow, he uses a bike pump. Oh, you're in Florida? Yeah, I'm in California. Florida and California are kind of similar, except you guys have humid weather, but it's like also pretty nice year round, at least from what I hear. I've been to Florida like once or twice, but not like in my adult life. I have a couple friends from Florida. All right, so he just uses a bike pump.
The first step is to assemble your Geo paintball marker. Your marker may have additional pieces, but the basic components are the paintball marker, the barrel, the paintball hopper mounted on top of the marker, and the compressed air tank mounted on the bottom of the marker. The Geo has a circuit board that controls the rate of fire, a trigger that transmits to the circuit board, the solenoid that releases the air, a regulator that controls the pressure of the air that is used, and the bolt that controls the airflow to the paintball. When the air tank is connected, the marker moves the compressed air propellant to a ready position in the solenoid manifold. As the trigger is pulled, a signal is sent through the circuit board that controls the fire rate. The circuit board then sends a signal to the solenoid that controls the airflow throughout the marker. The solenoid releases the air to move the bolt forward, sealing the rear of the barrel and releasing the compressed air propellant through the bolt behind the paintball, where it expands, forcing.
Wait, but that's the weird part. It's like
the compressed.
It presses it up. Can I make the cannon? Yeah, I can make the cannon, but if I was gonna do it, I'd want to put it on a robot. So that's sort of what this project is gonna be. Is it's not gonna use compressed air, but it's gonna be I don't have it with me, but it's I have this little robot that turns like this and it turns like this, up and down and left and right. And so the flywheels are going to be mounted onto the part that turns, and so it's going to be able to aim at someone and shoot it. So that's the goal of this project, and that's probably going to take a lot more time. And the eventual goal of that project is I'm going to have it paint a painting. So there's going to be something that applies some sort of thin paint to each of the balls and then shoots it at a canvas to draw like something. The first thing is just going to be like a smiley face, but hopefully we can dial in the settings and get it so that it actually makes a pretty picture, because I want to make some art and I want to get it in a gallery. I think that would be fun. But I mean, mainly I just want to get it to work. I don't know what image to make, so if you have an image that I should like, because the thing is, I basically only have a resolution of 100 pixels by 100 pixels. Going any higher than that would be very challenging. So what image is worth putting down that's 100 by 100 pixels?
Air propellant through the bolt behind the paintball, where it expands, forcing the paintball out of the marker. After the paintball is fired, the solenoid resets, readying more propellant and retracting the bolt, allowing another paintball to feed into position. In addition to retracting the bolt, after the paintball is fired, the solenoid resets, readying more propellant and retracting the bolt, allowing another paintball to feed into position. In addition to semi-auto, the Geo has ramping fire modes. Ramping allows the marker to enter 3-round burst or fully automatic fire modes after a specific speed or pattern of trigger pulls. In these modes, the paintball marker can cycle through each step of firing 12 to 15 times per second, firing a paintball each time. The Geo also has an easy to...
I wish someone could take one of these apart. Oh, dude. This guy is making...
My name is Major Sergeant Private Major, and I'm here to teach you about physics and making a delicious pasta sauce. First things first.
Why doesn't this have more views?
I need to let you know
this guy is sick.
This is the R0M4 launcher. It features a quad-barrel pneumatic design with each air chamber capable of handling up to 120 psi of pressure. In simple terms, air go boom. Its chief payload is garden variety tomatoes. However, many other options are also available.
Bro, because I was thinking that's so funny that he yeah, I would love to just make stuff professionally. See, the thing about this is I was thinking the YouTube title for a video like this would be, at least for the auto turret that I'm building, is every time you make a mistake in Guitar Hero, get shot at with tomatoes. So you'd like be playing Guitar Hero and then you make a mistake and he shoots a tomato at you.
Now, you can see at the end of the target range I've mounted a pot to a board. We're going to use that to make the basis for our sauce. First, you're going to want to get yourself some nice juicy tomatoes. Now, you might be thinking about dicing.
Oh wow, Mark Rober commented on it.
But here we're not about wasting time. Knives take too long. Cleaning out your blender, complete nightmare. Instead, we're just going to take our tomatoes whole, load them right into our launcher, and blast them into the pot. Voila! We've pulverized our tomatoes in half a second. We're making good time. Next, you're going to want to add some flavor. To do that, we'll need some herbs. If you just load them in loose, they're going to fly out the end in a cloud of seasoning shrapnel. Complete waste of money, we can't have that. Instead, we're going to make a sort of herb butter. Mix it all together, throw it in the refrigerator for a couple minutes.
What the hell? Oh, thanks. That's nice of you. Yeah. You could sub to me on YouTube. That'd be great. You sub to the VOD channel, the video, you sub to you sub to this, you'll help me out. Or on TikTok. But do what you want. I'm not gonna force you to do anything.
Load it into our launcher and
It's so crazy. Dang. I feel like flywheels are so much lamer than compressed air. Compressed air really, because like, what is the physics on like, is it this video?
Adjust regulator to chronograph your marker to the proper 300 feet per second speed. Adjust regulator to crawl each time. The Geo also has an easy to adjust regulator to chronograph your marker to the proper 300 feet per second speed.
Did you say chronograph? I just want to see a bunch of diagrams. Where's the hopper?
Through the marker. At this point, it is pressurized and ready to fire. The marker.
Okay.
Hey guys, Lord Odin here. Today we're going over the basic operation of the Tippmann A5 marker. Although the diagram shows an A5, the information can be applied to the X7 blowback, 98 custom, and US Army line of markers such as the Alpha Black, Project Salvo, and Carver 1. They may appear different on the outside, but on the inside the cuts are almost identical, and you may often find that the parts are interchangeable from marker to marker, depending on the model. Some of you may already be familiar with MEF's animation.
Where is it? Oh, do I not have a TikTok link? Hold on. Should be this. No? What is my TikTok? Hold on, I gotta mute this thing. It's probably gonna show some cringe ass stuff. Oh yeah, you have to put an @ before it. That's crazy that I haven't done this yet. I thought I had all my links up to date. Hopefully this is muted. Okay, let me just edit this. Oh wait, how do you edit this though? Edit panels? Oh wait. But how do I get these? Okay, well, whatever. Wait, I have 224? Really? Oh, wow. Cool. Okay.
But I've painstakingly converted it over to Flash so that we can get a better understanding of the mechanics of the marker. So let's begin. Once a tank is connected to the ASA, or air source adapter, air will enter into the gas line and through the ASA plug. Air now enters the tombstone, where it is funneled into a narrow channel prior to entering the valve. It goes through the valve O-ring and washer, around the valve spring, and stops at the valve plunger. The plunger creates a seal against the valve seat and prevents air from continuing through the marker. At this point, it is pressurized and ready to fire. The marker won't fire until the rear bolt, or hammer, is released by the trigger. The hammer waits under tension by the compressed drive.
Oh, that's smart. So you pull this trigger, this thing comes down, this launches forward, pushes this plunger. This plunger opens up this thing, a huge thing of, huge rush of air comes through here, pushes this back into position, which clicks onto there, pushes it down and comes back. So then that means that this is stopped again, and this is back. So it self-rights itself. But then where does the air
spring
go?
Inside of it, but is held in place by the trigger sear. The drive spring pushes on the hammer and in turn pushes on the sear. The operator squeezes the trigger, which rotates around the pin and lifts the front of the sear. The sear also rotates around the pin until the lip of it clears the hammer. Once that happens, multiple things happen simultaneously. The trigger sear is pushed backwards by the sear spring and is reset, where it waits for the hammer to return. The hammer is connected by a linkage arm to the front bolt, and the entire assembly moves together in unison by means of the drive spring pushing on the hammer. As it moves forward, the entire assembly builds up momentum. The front bolt is pushed forward and in turn pushes the paintball into the detent. The detent folds downwards out of the way, and the paintball passes through the barrel adapter into the breech end of the barrel, followed by the front bolt. At the same time, the hammer enters the power tube and the O-ring creates an airtight seal. The hammer then strikes the valve pin on the valve plunger. It pushes the plunger forward and breaks the seal inside the valve, allowing the air to escape. Air travels in two different directions at this point. Firstly, it travels backwards into the cavity created by the walls of the power tube, the face of the hammer, and the face of the valve. This is referred to as the blowback gas.
Yeah.
This air builds up pressure inside of this cavity and, combined with the valve spring, begins to reset the marker by driving the hammer, linkage arm, and front bolt backwards.
Yep.
Secondly, the air splits into two halves and turns 90 degrees on both sides of the valve. We'll refer to this as the propellant gas to differentiate it from the blowback gas. Here, the air yet again diverts into two directions. One way is through the side of the marker where air powers the cyclone or response trigger, both of which operate on the propellant gas, not the blowback gas that pushes back the hammer. The other way has the air turn 90 degrees and channels it forward through four grooves located outside of the valve. If you have an older style A5 valve or a low pressure kit valve, there will be two large grooves instead of four smaller ones. Once past the tombstone, the air converges in a small pocket of the power tube where it is then funneled into the power tube's small extension, which allows the front bolt to slide back and forth. The air travels through the extension, through the front bolt, and finally pushes the paintball through the barrel. Now the marker has fired and needs to reset. At this point, the hammer continues traveling backwards until the valve plunger creates a seal against the valve seat again, cutting off air supply to the marker. Once the hammer O-ring clears the end of the power tube, most of the gases expelled throughout the back of the marker come from this small cavity. The momentum of the hammer continues to drive it backwards and compresses the drive spring.
Wow, that's a really well-tuned thing. What's my passion? Right now, I love making stuff. I love mechanical design. I love building things. Before I just did software, but now I want to do electronics, hardware, manufacturing, dealing with how things actually get made.
The hammer slides over the sear until it slams into the end cap O-ring. It then travels forward again until the sear...
So how did the ball get back in there?
Until it slams into the end cap O-ring. It then travels forward again until the sear catches the hammer and resets the sear. The marker is now ready to fire again. And that's it. This may seem like a complex operation, but if you open up your degas marker, study the parts, and move the assembly back and forth, you'll begin to understand what's going on. Hopefully...
When I made my coil gun video, a couple of you guys didn't think it was big enough. Okay.
I don't think that this is going to be a viable. Because I mean, yeah, I mean it needs to shoot something non-metallic and light and soft. This thing is sick though. $40 meters a second. Yeah, that's about what mine does, but his shoots a freaking metal rod. You're a digital artist? I'm not a big anime person. But I do like video games. Let's see. So I like old video like indie games. Like I like Faster Than Light. I like Super Meat Boy, although I don't play it that much. I mean, I like Skyrim and all the big RPGs. I used to play a ton of Call of Duty. Yeah, I'll look at it. Wait, can you just join my Discord and then I'll add you? Because I think my Discord's linked below.
The basic function of a regulator is to control pressure reliably and consistently. You take the upstream pressure, you regulate it down to a downstream pressure, which then provides the system a consistent flow for it to operate.
So a pressure regulator is used in a lot of different systems to control either downstream or upstream pressure as other things within the system change, whether that's flow demand or temperature or usage of different components that are somewhere else in the system. The regulator works to maintain those pressures, whether it be downstream or upstream, as all of that changes. Pressure regulators are built with many different components. There's really three groups that drive pressure regulator performance. One is the control element, so that is the poppet and the seat. That controls how much pressure drop happens between the high and low pressure sides. Next is the loading element. Most often a spring, sometimes can be a pressurized dome of gas, but it's what the users interact with. So as we turn the handle one way or another, we're compressing the spring or allowing it to relax, changing the forces inside of the pressure regulator. Now, the way that the control element and the loading element talk to each other or know what position to be in is through the sensing element. So the sensing element is very often a diaphragm or a piston. It senses what's happening downstream, how much pressure there is, and allows the poppet to know just what position it needs to be in to optimize performance.
The key function of a regulator is to control pressure, and that's done by essentially a balance of forces within the regulator. So we apply a load, be that from a spring or a diaphragm and a dome with pressure inside the dome, which gives us a downward force. The pressure coming into the regulator goes past a small pocket, which is not in contact with the seat, or nearly in contact with the seat. We have a very fine gap. That fine gap causes the pressure above the poppet to be reduced from the pressure below. That pressure above the poppet acts on a sensing chamber. A sensing element, a diaphragm or a piston, is pushed up. That balances the force from the spring, which is pushing down. When we reach the balance point of those forces, we get a state of equilibrium, and then the regulator is working at its set pressure.
I don't really get it, to be honest. Wow, people love coil guns. Oh, wow, it spins it? That is pretty crazy. Yeah, that's insane, man.
Oh shit! Now I have to sweep up the glass.
Wow. Cool. I'll check it out in a minute. I'm probably actually gonna end the stream. In a minute here. I'll follow you on Instagram. That's cool. You want to be an artist. I think we have somewhat similar aspirations. Okay, okay, so what do I have to do, bro? I gotta fix my 3D printer. It's broken right now. It's gonna be a pain in the butt. All right, Natasha, very nice to meet you. I'm gonna run.